So now we're going to pay attention to what each form of a quadratic equation tells you. We've been looking at two forms. There's three forms. So there's three forms to a quadratic function, and each form tells you something about the graph. Some take a little work, some that's right in front of your face. We're focusing this unit on the standard form and the factored form, and we'll deal with a vertex form next semester. The standard form is ax squared plus bx plus c. The a is the coefficient of the x squared. The a does not include this part, it's just the coefficient. The b is the coefficient or the number multiplied by x, and then c is your constant. The a tells you the direction. A, in this case, is 1, and since it's positive, we're going to have an upward facing parabola. This particular a is -1, and since it's negative, it's going to be a downward facing parabola. The standard form also gives you quick information about the y-intercept. The y-intercept is always when x is 0. So if I let x equal 0 here, I'd get 0 squared minus 6 times 0 plus 8, and sure enough, the remaining piece is just your c. So anytime you have the standard form, without doing any math, you can find the y-intercept by just looking at the c. In this case, the y-intercept is -8. It's hard because I just wrote over the negative sign there. We're not going to talk about this as much this semester, but the standard form also gives you opportunity to find the value, the x value of the vertex. You just take the b value and divide it by 2 times a. So if I were going to use this as an example, my b value is 6, and I would divide that by 2 times -1. That means that my vertex is going to be at 6 divided by -2. My vertex would be 3 something, and then I would go ahead and take that 3 and multiply it into that, or the factored form, to find the y value of the vertex. If you are interested in how A, B, and C affect the graph, you can go ahead and go to Desmos, click on that, and you can use the sliders for A, B, and C to just kind of get a really good sense of what's going on. But remember, C is always going to be your y-intercept, and A is always going to tell you whether it heads up or down. Factored form allows you to easily find the x-intercepts. And the x-intercepts are also called the roots, the zeros, or strangely enough, when we're talking about quadratics, the solutions. X-intercepts, if I'm drawing myself, no, let's not use that. If I'm drawing myself a quadratic, the x-intercepts are always right here when y is 0. And since any number times another number equaling 0, each of these has to equal 0, we're going to go ahead and set each of them equal to 0 and solve for x that way, and that gives us the x-intercepts. I know a lot of you can do this one in your head really easily. Right here, x plus 4 is 0, so we know that x has to be -4. And whenever it looks like this, we're going to go ahead and recognize that we're going to have a fractional answer. That just means that it's crossing the x-axis at a fraction. So we're just going to use our equation solving skills here. We're going to add 3 on both sides. After a while, a lot of you can do this part in your head. I know you can. 2x equals +3, so x is going to equal 3/2. So the two places that this particular parabola crosses the x-axis are at -4 and 3/2. The last form of a quadratic is the vertex form, and we're going to deal with that in second semester. But the vertex form is really helpful because it gives you right here, you're going to pay attention to this piece, and that's going to give you the information about the x value. And you treat it the exact same way. I'm just giving you this information for future reference. you treat it the same way. The x minus 3, you're going to treat it the same way as your factors setting equal to 0. So the opposite of this number is the x value, so it's 3. And then the other number, so this is going to be the vertex of that particular one, and here you are sure enough at 3, -2. But we'll get more into that in the second semester. So we're going to go ahead and put all that together to graph some quadratics. These two example ones, you can come back to this part or look at it right now. I've got the standard form. I've got the factored form. I can look in between to find the x-intercepts and then go on from there. But you can come back and look at those after I've explained how to do each step. So let's put this back so it's easy for you guys to look later. So linear functions are, you just need 2 points. Once you have 2 points, everyone's going to have the same exact graph. So let's say we have the point 5, 2 and -1, 7. Everyone's going to graph out 5, up 2, and -1, 1, 2, 3, 4, 5, 6, 7. Everyone's going to have the same line, assuming, of course, you can draw a straight line, which I cannot. From there, we could find the slope. We could find the y-intercept. We can write the equation in standard form or slope-intercept form. You just need 2 points, but that's not true about quadratics. Quadratics, we need more than 2 points, but not a ton. We basically need the vertex. We need to know if it's heading up or down. And then you need 1 or 2 points on each side. So the x-intercepts will normally count as one of the point, and the y-intercept will normally be another point. And then you can just go ahead and use symmetry to help you. So the first thing we're going to do is we're going to look at the standard form, which tells us, right, here's the a of 1, so we know it's going to be a parabola heading upwards. And then here's our y-intercept. So then we're going to go ahead and put that information already on the graph. Here we are at 3. Nope. Here we are at 3, and we know we're heading up. Then I have factored it already. Once we have the factors, then we can go ahead and find the x-intercepts. And remember, we do that by letting y equal 0, because that's where the x-intercepts are when it crosses the x-axis when y is 0. So then we're going to go ahead and solve these two problems. Once again, I know you guys, a lot of them can solve it in your head. So x minus 3 equals 0, x has to be 3, and x has to equal 1. So then we're going to go and look at what we've got so far. We've got a 3, a 1, whoops, a 1 and a 3. That means that right here we see the line that cuts the parabola in half, and that means the vertex has to be somewhere down there, but we don't know where. So what we're going to do is we're going to look at the x value of the vertex. Is it there at 2? And that means we're going to have to go ahead and plug in 2 into our equation. So we can plug 2 in, either into our standard form or our factored form. And I'm going to plug it into the factored form because it's easier for me to do. I'm going to put it way up here. So I'm going to take the fact that this is x is 2. I'm looking for the vertex. And the vertex is going to be 2 something. I'm going to plug in 2 into my equation. So here is the factored form of the equation. I'm going to put 2 in for x in both cases. And then I'm going to go ahead and do the rest, 2 minus 3 and 2 minus 1. Once again, I'm taking that from the factored form of the equation right down here. But I could also use the regular form, the standard form. So I'm going to go ahead and do the math here to find my y value, my vertex. So let's look back at what we've done. We've looked at whether it headed up or down with a... There's my husband screaming at the Warriors game. Positive, going up. y-intercept here at plus 3 because y-intercept is an x is 0. We factored it because x minus 3 times x minus 1 is the same thing as x squared minus 4x plus 3. The x-intercepts are when each factor is set equal to 0, so x is 3 and x is 1. And then we can go ahead and realize that the vertex is going to be, at 2 something in between the two y-intercepts. So x-intercepts, so we plug it in and we find out that it's going to be 2, negative 1. And then we have our parabola. All graph.